Hey everybody, what's going on? I just wanted to check out some of the questions and feedback I got from the circuits ed puzzle. So here we go. The only concern that I have is remembering the formulas. Other than that, a complex circuit is just solved by breaking it down into simpler parts, which I think I understand as well. Cool. Luckily, not having to remember the formulas. Well, obviously, we're working from home. That's kind of good. Also, there is a few sometimes on the reference tables, and then honestly, the more you work with this stuff, you do kind of remember a lot of this. It goes with anything else, I guess. Unfortunately, if we were in school, we'd be delving a bit deeper and a little more hands-on. And anyway, let's see what else we got. Complex circuits seem like a misleading name. It doesn't seem very complex. However, could you add a few questions forcing us to solve problems ourselves? Sure. So I'll post some questions, complex circuits with answers, and let me write that down. Sampies. All right, what else we got? How can you identify if a circuit has both parallel and series aspects to it? So you get used to the battery symbol. If you just start going through things or, a light bulb, stuff like that, and you make your way back to the battery, if there's no break anywhere and it doesn't split in any way, then that is definitely a series circuit. Parallel, we show in a couple of different ways. Sometimes we'll just show it branched off like this. Maybe this is two light bulbs in parallel with each other with a resistor there. So if you follow the wire, there's some sort of split somewhere, and that shows you then that these things are running in parallel. The other way you'll see it drawn sometimes is up, and maybe you'll just show it like maybe like that. You'll see a parallel like that sometimes. Depends on the person doing the drawing. Typically with schematic diagrams, as these are technically called, you really just try to keep to 90-degree turns and simplify everything as best as possible, but it kind of comes down to these two different ways of showing parallel. All right, what else we got? I'm lost. I watched the whole thing. Uh-oh. Watch it again. Have the notes you write on the board match up with our packets. Okay. Notes match. See what I can do about that. I think everything was addressed. Cool. I followed along pretty well. I think I understand it. I don't really have any questions. Cool. No questions. Length and power consumption. If one bulb is closer to the battery, it would be brighter or last longer than others. That is pretty cool. I'll check that out. Often we kind of oversimplify. Perhaps if you're in a tech class or something, the reality of circuitry is involved here. We just like ignoring friction. We kind of assume a lot of the wires in our diagrams are kind of have no resistance and things like that. It's a little oversimplified, but I'll check that out. I think the video helped a lot solving complex. Cool. Equivalent resistance. Had trouble with that. We should flip. And when we should flip. All right, cool. So with parallel is the time it's a little bit weird to add up. It's not just adding the actual resistors. It's where you need to use that reciprocal thing. So wait, hold on. What's the question again? Trouble when you should flip and when it's reciprocal. So these are both parallel circuits. So if this had a 2 ohm resistance and a 2 ohm resistance, and this would be the same scenario, for example, when it's in parallel and there's a break, then you need to add it with that reciprocal formula. So it's 1 over the total is 1 over 2 plus 1 over 2, which I guess is 2 2s. We saw that recently. You do have to flip it because it's really 1 over what you're trying to solve for. So when you do add up the fractions, you do need to flip it in order to get the value. In that case, it would just be one ohm there. If it is just in a straight line, so if you had a battery, can you see this? Cool. Battery, and then back to the battery there. So these things, I don't see a break in the wire anywhere. It's just one path. So again, that is series. And this one, if you had a 2 and a 2, well, then you just add it up. So resistance total is just 2 plus 2 or 4. And again, it's a shame we can't do it in real life because you would often kind of see that when you hook up light bulbs this way, the resistance is kind of high because they get very dim. And they get very dim because there's low current flowing through them. Whereas these would end up equally bright. And again, I hope you get your hands on some electronics at some point. What else? I understand it so far. Thanks. Questions? Cool. Probably more stuff about wiring. You've been explaining some word problems. Okay. Word cues. All right. Not something that would be addressed about this process next time could be solving when not all the values of the resistors are given. Oh, cool. So that would be kind of solving some stuff backwards, I guess. All right, let me write that down. Solving. All right, check that out. I'm not sure. I think I understand. I currently don't have any questions. How to solve when you give the total value but not resistor value? All right, this is the second time I saw that. All right, cool. I was just wondering tricks to do it quicker. Honestly, when I'm going over it, I got to kind of go over it from the novice point of view and sort of go through it a little bit more slowly. Tricks, just I think with experience, it kind of comes with time. I don't have any good tricks for you at the moment. I'll think about that. I don't know. I think I got it. All right, next time, address how to figure out the resistance if you don't know one of the elements. Cool. Where'd you guys get that concept from there? I'll have to address that out. All right, so if you don't know, that's the third person. All right, is it going to be scenarios where one resistance is not given? Was that in one of the other ed puzzles and I missed that or something? But no, I wasn't really going to hit you with that because we are not going super deep into everything, unfortunately. The whole practice one. All right, I got two other complex ones now that you can check out. I understand the process. It's unclear. Maybe use darker marker. Oh, and glare. Okay. All right. Well, I got all my markers. I got my markers after a month and a half on Amazon there. All right, I'll work on the glare. I know some of the glare can be distracting. Good explanation. All right, I try. Sometimes I get confused when to use what formula when you don't have all the information. I know we have to use multiple formulas. I get confused. You should put questions in the videos. If they're easy multiple choice, stay focused. Okay. All right. Yeah, I was going both ways. With some of the ed puzzles, I don't want to ask like dumb questions, but it was good because I know then that you're kind of at least giving me feedback and I can see all that, so it's helpful. All right. Yeah, and then I was going either way. Sometimes I don't want to make you answer dumb questions when, I really just want you to watch it, and I just ask something at the end. All right, cool. Good job answering questions. Okay, is there any limit to how many times a circuit can switch from series to parallel? No, not really. I mean, this stuff can get absolutely wild with different pathways. There can be all sorts of stuff. How much faster is a 2-bulb parallel circuit drain energy in a 2-bulb series? Is it twice as fast? Ah, cool. I'll have to address that deeper. That's a really good question. It's really neat. So what it's asking is, when you hook up in series, there's low current flow, so your battery will typically last longer, but you'll have like dimmer lights. If you hooked up the same exact light bulbs in parallel, they would both be getting the full potential of the battery, and they'll both be equally bright. But then that drains out your battery very quickly. I'll have to check the numbers and stuff off the top of my head. I don't really know like the twice as fast part. I'll check that out. What was really neat when I was a kid, the nickel cadmium batteries for remote control cars, you really wanted to run them all the way out, meaning the battery be totally, no more energy before you recharge them. That would be the best way, and you want to fully recharge them and then not keep charging them. And that was the best way to keep your battery as healthy as possible. So it was a really neat guy down at the bike shop. He was into this stuff, and he showed me, he made these little parallel light bulbs. He had about 12 of them all linked in parallel. And when his battery was no more fun to play with the remote control car, he would then plug this into the battery, and it would so quickly drain the battery down. It was a whole bunch of light bulbs in parallel, and it would totally drain the battery down. You'd watch the lights just be super bright and then all go down. And it was really clever. It was a way of like getting all the rest of the energy out of the battery pack. But I'll have to check that out. That's cool. How do you tell a complex circuit? How can you tell a complex circuit has both series and parallel? How can you tell? Yeah, so it's just going to come down to like, when you leave the battery, identify the battery and then follow the pathway. Does it go right through something? Well, then that's series. If there's some sort of split and then it goes through stuff, well, then you have entered some part where there's a split. It's not series anymore. With complex, though, then we can then go back. There could be another resistor down here, for example. We can come back. We could see the wires come back together, and then there's only one way to get back to the battery. You could think of this as like pipes where there's water flowing through a pipe, but then there's choices of which way to flow, and then the pipes come back together and then flow, back to the battery there. So if there's some sort of split, you're definitely entering a parallel section. Questions for you address is the process same for mixed circuits. So this is sort of mixed circuits. These complex circuits is another word for mixed circuits. So I'm not sure what that's about. I think it's good so far. Question going through the process. Why do you need to use reciprocals? Why can't you get it without it? That's actually a really good question. Off the top of my head, let me just see, kind of how I understand it. Let's see if it makes any sense. So with parallels, having multiple pathways, for the current to flow down. When you have multiple pathways, we say I total equals the I, maybe that goes down one way, I1, plus the current that goes down the other way, I2, and then if there's more, we keep adding them. So my interpretation of why we use the reciprocals is if we sort of replace I here, and maybe there's a better explanation. Let me look into it and I'll get back to you. But if we kind of replace everything, thinking about Ohm's law, once again, the most important formula in all of circuitry, what would I be? I would be V over R. So if we kind of take everything and replace it with the voltage total over R, and then the voltage V over R plus V over R plus, however many more there are. If you kind of then factor out voltage, you're kind of left then with resistance total is the addition of all the resistors, but it's reciprocal. I'll look deeper into that, see if I can get back to you on that. I don't know. Very helpful. It was good. You explained steps. It would have helped if you explained why series rules apply to series circuits and same with parallel. All right. Yeah. That's cool. So why are the rules the way they are? So let's just kind of quickly look at the rules. Sorry, it's not fully erasing anymore. With series circuits were there's the I total, I like the current that leaves the battery, and it is the same everywhere. So it's the same in location 1 as it is in location 2 as it is in location 3. So what's up with that is with series, there's, with series, there's only one pathway. So the current is going to be whatever, the pipe, if you will, the flow moving through it is going to be the same here as it is here, as it is here. There's only one path, so there's going to be one flow rate everywhere. So it's kind of like this is saying the same thing, but in kind of formula terms. But that's why, like we say, the current is the same everywhere. With parallel, I run out of room. Okay, parallel, we'd say I total is I1 plus I2 ... Because with parallel, do I have room here? Yeah. With parallel, some of the current leaves the battery, we call that the current total, but then some of the current goes down each branch. So there's more than one pathway, you end up with more than one current, and that's why I kind of often remember if this is the way it is in series, then it's the other way in parallel. And I mean, that's kind of how I remember a lot of this stuff. What else we got going on? So series voltage. We say in series voltage, there's little drops at each location, but those little drops add up to, what the battery had to offer. Kind of what's going on in series is, I see often an analogy between electric potential and gravitational potential. So it's kind of like what the battery is doing is almost like lifting the electrons up the ladder of a slide. When you have things connected in series, the battery lifts all the electrons up, and then it does some work at the first thing, and then does more work at the next thing. Wow, that doesn't look good the way it's angling out. It doesn't look the same here. Sorry. Let me see if I can fix that. So the battery is giving the electrons like a potential, and then each thing in series is sort of getting back to ground level here, and then back to the bottom of the slide. The battery pumps it back up to the top, if you will. What's kind of going on with parallel is it's sort of like there's multiple slides. Like everyone gets the battery's full potential. Everyone gets lifted up to that energy level, if you will, and then they all drop through kind of through that same potential drop. So that's why we say, the voltage in parallel equals wherever it is at location 1 is the same at location 2, ... I hope that makes some sense. Let me see what else we got. And then what else do we keep track of? And then resistance, sorry. And resistance. So when things are in series, we say resistance 1 plus resistance 2, plus whatever, however many more you have. The way I kind of think about it is there's only one pipe. So it's almost like the battery has to push electrons through this device. While it's doing that, it's also pushing on the same, almost think of it as the same pipe. It's pushing at the same time through that second one. So this adds up to a lot of resistance then. And this is the way that mathematically it adds up quickly. Whereas in parallel, we'd say 1 over the total is 1 over each resistor, R1, R2. And it doesn't add up as much. And just maybe maybe I should understand it deeper as well, but just what has always kind of made sense to me is with multiple pathways, it might be hard to go down this one, but the battery doesn't have to pump everything through that one. It can also pump it, in a sense, through this one. There's multiple pathways, so resistance adds up to be quite small. Anyway, hope that helps. Oh, there's that glare. Actually, I think I understand it surprisingly. Cool. All right. Later, guys.